January 2021, question number 10. This says, given the matrix W is equal to 3, 6, minus 2, 5, we're to determine the 2 by 2 matrix L such that W plus L is equal to 0, 0, is equal to the 0 matrix. So I'm going to call this matrix B. So W plus L is equal to B. So it means therefore that L would be equal to B minus W. So B would be 0, 0, 0, 0 minus W, which is 3, 6, minus 2, 5. So matrices of the same order may be added or subtracted by adding or subtracting corresponding elements. So this is 0 minus 3, 0 minus 6, 0 minus 2, which is plus 2, and then 0 minus 5. So the answer L is the matrix minus 3, minus 6, 2, minus 5. All right. Next, we're told that the 2 by 2 matrix P, we're asked to find the 2 by 2 matrix P such that WP is equal to 1, 0, 0, 1. 1, 0, 0, 1 is the I matrix. Now, when you multiply a matrix by its inverse, you're going to get the I matrix. So it means that the matrix P must be equal to the inverse of W. Whenever you multiply a matrix by its inverse, you get the I matrix. So if I'm multiplying W by P, I'm getting the I matrix. It means that W must be the inverse, P must be the inverse of W. Now, W inverse is equal to 1 over the determinant of W times W adjoint. Now, the determinant of W, so W is 3, 6, minus 2, 5. So it's going to be the product of the leading diagonal elements, 3 and 5. So it's 3 times 5 minus the product of the logging diagonal elements, 6 and minus 2. So this becomes 15. Minus is plus. 6 2s are 12. This is 27. And so W inverse, which is P, is equal to 1 over 27 times W adjoint. So you're going to switch the leading diagonal elements, W adjoint. You're going to switch around the 3 and the 5. So 5 go up here. The 3 goes down here. The 6 and the minus 2 stay where they are, but their signs change to minus 6 here and positive 2. So P, which is W inverse, is equal to 5 over 27 minus 6 over 27, 2 over 27, 3 over 27. So P is the matrix 5 over 27, 2 over 27, minus 2 over 9, positive 1 over 9. So this is the matrix P. Now B says the right angle triangle M has vertices x11, y31, z 34. When M is M is transformed by the matrix N, which is 0, 1, 1, 0. The image of M prime is. Now, whenever you have applying um, a transformation um, given as a matrix to points, you must multiply the transformation by the points. So let's multiply the points by n. So we're going to get n, which is what? 0, 1, 1, 0, multiplied by the points. The points are x, which is 1, 1, y, which is 3, 1, and z, which is 3, 4. All right, so you must take care to ensure that you can multiply the matrices, because multiplying the matrices is either you're going to put you're going to put n at the front or at the back. But if you're, well, you put n at the front, you must put at the front. At the back, it won't work. So you put n at the front. So let's multiply row by column. So we're going to multiply the row by column x. 1, 0 times 1 is 0, 1 times 1 is 1. So this is 1. We have x prime here. Top row, y prime. 0 times 3 is 0, 1 times 1 is 1. So we have 0 plus 1, 0 plus 1. We have 0 times 3 is 0, 1 times 4 is 4. Z prime. No, bottom row, 1 times 1 is 1, 0 times 1 is 0. 1 times 3 is 3, 0 times 1 is 0. 1 times 3 is 3, 0 times 4 is 0. So this is x prime 1, 1, y prime 1, 3, and z prime is 3, sorry, 4, 3. 4, 3. All right, and we're asked for the image. All right, so x prime is the point 1, 1. So with this transformation, x and x prime is the same point. Then we have what? Y prime is 1, 3. The x and the y coordinates interchange, and z prime is 4, 3. The x and the y coordinates interchange. So for this transformation, the x and the y coordinate interchange. And I think the transformation that does that is reflection in the line y is equal to x. All right, so the C part is vectors. It says the diagram below shows triangle OPQ, in which OP is 3U, OQ is V, Q is the midpoint of OR, M is the midpoint of PQ, L is a point on OP such that OL is 2/3 of OQ. So if OL is 2/3, it means that OL is 2/3 of OP. So if L is 2/3, it means that LP is 1/3. I is asking us to write in terms of U and V an expression for LM. So I need LM. LM would be this vector here. All right, so that's a vector LM. I could say that LM is equal to LP plus PM. Now, PM is equal to PO plus O. PM, sorry, it's not PM, PQ. I need PQ first. Before I go to PM, I need PQ. You'll see why in a second. PQ, in order for me to see what PM is, I need PQ. This is PO plus OQ. So since OP is 3U, PO is minus 3U, plus OQ, which is V, put in the positive first, this is V minus 3U. Also, now PM is equal to a half of PQ. So PM is a half of V minus 3U. All right, we needed PQ in order to get PM. No. So LP is U plus PM, which is PM, which is 1/2 of V minus 3U. Let's make this simpler because we can. LCM is 2. 1 into 2 is 2. 2 times U is 2U. Plus 1, 2 into 2 is 1. 1 times V minus 3U is V minus 3U. So now we have V minus U over 2. Or we could say this is a half of V minus U. So LM is equal to a half of V minus U. Next, we need PR. We need PR, P, all the way down to R. That's PR. We need that vector. All right, PR would be PO plus OR. It's not hard. This is PO plus OR, triangular vectors. This is minus 3U plus 2V. This is 2V minus 3U. Now we're asked to prove that L, M, and R are collinear. M, L, and R are collinear. Now, we already found LM. Now we need to find LR. So we need the vector MR. So MR, I could say, is equal to MQ plus QR. Now QR is also V. OQ and QR are the same length and it's one straight line. So if OQ is the vector V, QR is also the vector V. All right, so this is, we need MQ plus QR. So MR is equal to MQ plus QR. MQ is a half of PQ. And QR is V. I think that this is actually a half of what V minus 3U. Not sure, let's check it out. It's V minus 3U. So this is a half of V minus 3U plus V over 1. LCM is 2. 2 into this is 1. 2 into 2 is 1. 1 times v minus 3u is v minus 3u. 1 into v is v. 1 into v is 2. 1 into 2 is 2. 2 times v is 2v. So this is actually equal to 3v minus 3u over 2. 3 is common at the top. This is 3v minus u over 2. This is the same as saying 3 over 2 times v minus u. So this is MR is 3 over 2 v minus u. All right, and I think LM was a half v minus u. A half v minus u. So you notice that the end part, the letter parts are the same, v minus u. So that means that MR and LM have the same base vector. If they have the same base vector, they are parallel, and M is common. So MR and LM are parallel, and LR and LM are parallel, and M is common. Therefore, L, M, and R are collinear. All right, and the word collinear there means are in the same straight line. That's the end of the question.